Hello everyone. Let's understand the reason for the ambiguity problem in any grammar. So I will take the same example which I will take in the previous video. The grammar is E derives E plus C, E star E or simply ID. And here I will take two different strings. The first string is ID plus ID into ID and the second string is ID plus ID plus ID. And I will draw the corresponding parse tree for this string. So here we know that this particular grammar is ambiguous, therefore we got more than one parse tree here. But if you consider a number in place of this different ID, let's say the number will be 2, 3 and 4. Okay, so 2 plus 3 into 4. 2 plus 3 into 4. Then which parse tree from the above two parse tree, which parse tree will get the correct result? We have to test it out. So here I will replace 2, here I will use 3 and here I will use 4. So in this particular parse tree, 3 into 4 is evaluated first, means the star is getting higher priority. But in this parse tree, which is here, the plus addition is having higher priority. So the ambiguity problem is due to the precedence and associativity. If the highest if the highest priority operator is evaluated first, then the particular parse tree will get the correct result. So in this particular parse tree, we will get the correct results. So what will be the result? 3 into 4, which is 12. 12 plus 2 is 14. And this parse tree will get the correct result. And what about the other parse tree? In other parse tree, first we try to add the two numbers, which is 2 plus 3, 5, and then after that we multiply the third number, which is getting the wrong result. Okay, so in this particular example, the problem is precedence problem. Okay, what is precedence? Precedence is basically defining the priority between different operators like plus, addition, multiplication, addition, subtraction, division and other operators also. Coming to the second string, W is equal to ID plus ID plus ID. In this string, you notice that here I will use the same operator 2 times plus. So which parse tree will get the correct result if I have same operator in a particular string? So we already know that the addition operator is left associative. So this particular plus we evaluate it first and then after we evaluate the result with this plus. So according to this associativity rule, this parse tree will get the correct result. Okay, so here the problem is associativity. Okay, so we have two problems in ambiguous grammar. First is the precedence and the second is the associativity. If we manage these two problems, then we can convert the ambiguous grammar into unambiguous grammar. So first, the precedence rule. What is the precedence rule? Precedence rule is used to resolve the priority problem in any ambiguous grammar. So the precedence rule says that any highest priority operator is evaluated first. If it is evaluated first, then it will be farthest from the start symbol. So the start symbol is E and here star is farthest from this particular start symbol and plus is closest to the start symbol. So any highest precedence operator will farthest from the start symbol. So high priority operator is at farthest level in grammar. Okay, and lowest priority operator is at closest to the start symbol. Okay, coming to the associativity rule, The associativity rule. Same precedence operator. So we have defined two associativity here. First is the left to right and second is the right to left. So like here, addition is left associative. So left associative operator is called left recursive grammar. Okay, so left means whenever you got the operator which is left associative, then you have to evaluate it like this. Means the parse tree will grow in left direction. Okay, and whenever you got the right recursive right associative operator, then the parse tree will grow in right direction. So right associative operator is called right recursive grammar. Okay, so according to the precedence rules, the highest priority operator is evaluated at the farthest level, means at the downward. And coming to the associativity rule, the left associative operator if the operator is left associative, then the parse tree will grow in left direction, and this particular left associative operator is called left recursive grammar. Right in right associative, the particular parse tree is growing in right direction and the grammar is called right recursive. Okay, so you have to remember these two rules, and using these two rules we can easily convert ambiguous grammar into unambiguous grammar. For example, this ambiguous grammar can be converted to unambiguous, it is converted to an ambiguous grammar like E derives E plus T, plus is the lowest priority operator, so I can write here E plus T, or simply a T. Then T derives T star F, or simply F, and F derives ID. How can we read this grammar? The grammar is expression plus term or term. Term is term into factor or factor. Factor can be an identifier. Okay, and this is unambiguous grammar. How? Because here the precedence is already decided. Star is having higher precedence than plus, and associativity is also decided. Here the plus is left associative because the leftmost variable is equal to the left hand side variable, and here also the leftmost variable in right hand side is also equal to the leftmost variable left hand side variable. Okay, so plus is left associative, star is also left associative, and coming to the precedence, star is having higher precedence than plus. Okay, so let's take one more example to understand the ambiguous and unambiguous grammar.